All right, these notes, nice and short and sweet. They're about the periodic table organization. We're finally going to get those elements into the periodic table and talk about how they're organized. All right, these notes have just 2 questions, so they're pretty short and simple. Let's get started with our first question about a guy named Dmitri Mendeleev. All right, first question, who is Dmitri Mendeleev? Now, please do not get him confused with Gregor Mendel, which you learned about last year in biology, the pea guy with genetics, and he did the little pea plants and all that stuff. Completely different guy, but unfortunately, they have the same root for their name. This guy, though, Dmitri Mendeleev, was a Russian guy who was the first to organize the elements into a periodic table. All right, this guy was a genius. All right, now he lived in the 1800s, so there wasn't as many elements to put in a periodic table, but he obsessed with organization and figuring out exactly which elements were like each other and where they should go and everything. He like dreamed of it. Okay, that's how obsessed he was. So he put his life and work into the periodic table. So let's take a look and see how he organized it. All right, so this is actually his first periodic table. It looks nothing like the periodic table that we know of today. There are some similarities. He has groups up here, groups 1 through 8, and other than that, there's no like little blocks or chunks or organization. It's just numbers and letters. Okay, but it was the start of genius here. Okay, so when he was doing this, Mendeleev organized them by 2 things: reactivity and atomic weight. All right, so he organized them by reactivity, which is the speed at which 2 substances will react with one another. Okay, so substances, if you mix them together, okay, they are going to react really, really slowly, if even at all, if you can even see it at all. And some, when you get them together, will go real fast. Okay, so that's called reactivity. So what he did was in each column, right, he put the ones that were least reactive up top and the ones that were most reactive near the bottom. Okay, except we'll see in our next notes that's actually the opposite in group number 7. He also organized them by atomic weight. That was the second parameter. And atomic weight is the average weight of protons and neutrons in an atom. And when we talk about the atom, starting next week in our notes, we will talk about average weight and what protons and neutrons are. You should know what protons and neutrons are from 8th grade science and previous sciences. But if you don't, we will get there. So don't worry about that right now. All you need to worry about is, knowing that Dmitri Mendeleev is the one who organized the periodic table or the elements into the first periodic table, and he did it by reactivity and atomic weight. Okay, so we're going to take a look at the modern periodic table, since that's what we're going to use in class, and we're going to see how it's further organized. All right, so here's a picture of the modern periodic table. It is grossly simplified. Doesn't have all of the information like the weight and everything on it. It doesn't have the full names. It just has the chemical symbols. But we get the idea of how it is structured here in this picture. Now let's take a look and see how it's further organized. Okay, first off, the periodic table is divided into what are called rows and columns. Okay. Now, instead of rows, we call them periods. Okay, so going across the periodic table is, going across a period, and going down the periodic table is what we call a group. Okay, so groups go down, Another word for group is families. They're kind of used interchangeably. So groups and families are down a column, and going across from left to right is called a period. Okay, so that's the first way they're organized. And it's probably a periodic table because of the word period going across the rows. Okay. What we're going to take a look at next is the different group names or the different family names that we have on the periodic table. Tomorrow in class, you're going to be coloring your periodic table with the different group names. So make sure you've printed out your periodic table and put it in the back of your notebook, and B, make sure that you've listened and paid attention here so that you can do it easily. So let's take a look at these different group or family names on the periodic table. All right, so if I were you, I'd kind of just sketch a skeleton outline of the shape of the periodic table on your notebooks. Okay, that way you can kind of see how it's all labeled and stuff like that, and you can more easily transfer it over to your real periodic table tomorrow in class when we are coloring it all in. Okay, all right, so we're going to start by basically dividing the periodic table into two different sections. Okay, on most periodic tables you're actually going to see a staircase, okay, on the periodic table, usually on the right hand side here, and it's always in the same place. This staircase is here in order to divide the metals from the non-metals. Okay, so everything on the left side of that staircase is a metal of some kind. Okay, so that means it's a hard, shiny substance. Okay, so everything on the left hand side is a metal. Okay, and everything on the right hand side of the staircase is what we call a non-metal. Okay, it is not hard, not shiny, not a metal. Everything on the right hand side are non-metals. So that's the first easy kind of division of our periodic table here. Left side is metals, right side is non-metals. Okay, now we're going to take a look at actually before we go there, I need to show you guys the one exception, because there's always exceptions in chemistry. Just kind of confront it and go with it. Okay, everything I say, there's always an exception, but we're just going to go with the general rule. However, there's an exception to this metal non-metal thing, and that's hydrogen here. He's our little poser. Okay, he is a non-metal on the metal side. Okay, we'll talk in a future lecture why he's there, but for now you need to realize and you need to put it in your brain that hydrogen is a non-metal, even though he's on the metal side. Okay, he's a poser, a wannabe. Okay, he's a non-metal on the metal side. All right, if you get that in your head now, everything else will be much easier in the future. Okay, so that's the story of hydrogen. All right, so let's take a look at each of the different groups on the periodic table. They all have individual names, so we're going to go over the different groups on the periodic table and what their names are. All right, now we know metals from nonmetals. We're going to take a look at the different groups, or the group names on the periodic table. Okay, so group 1A. All right, so here, that's right here, group 1A is what we call the alkali metals. All right, now obviously it does not include hydrogen. He's, remember, the poser, the wannabe. But from lithium on down are what we call the alkali metals. Group 2A here, okay, are what we call, so here, group 2A, are what we call alkaline earth metals. All right, so those guys are alkaline earth metals, okay, from Be all the way down to Ra, beryllium down to radium. Okay, now in the middle, you see we have this short kind of column, short section right here. Okay, they are going to cause us lots of trouble in chemistry. Okay, so just try to love them now. All right, these guys, they're all called transition metals. Oh, transition metals. Okay, it's this short little group here in the middle. All right, they're the B group. If you notice right here, okay, they're the B group, and you know, we're going to call those the transition metals. Okay, now when we get over to the right hand side, all right, groups 3, 4, 5, and 6, okay, these guys right here, 3, 4, 5, and 6A, they have very boring names, okay, because they're just named for the element that starts off the group. So this one is called the boron group. Okay, again, not too exciting. All right, next one is called the carbon group. All right, again, not too exciting. It's super easy to remember, though, so I guess that's a good thing. The group 5 is called the nitrogen group, because N is for nitrogen. And group 6 is the oxygen group. Okay, so let's take a look at that. Oxygen. Now when we get to group 7 and 8, we get cutesy little names again. Okay, so group 7 is what we call the halogens. Okay, so group 7 is the halogens. And group 8, you probably all know and recognize, hopefully, as the noble gases. All right, so these guys are noble gases. As you might have guessed, yes, they're all gases, and we will be talking in a couple weeks about why they are so noble. Okay, now the last two little columns down, or periods down here on the bottom, have their own names. The first row here is called the lanthanide, and the second row or period is called actinide. Okay, so those are the lanthanides and actinides, and they actually fit in right here. So they are kind of like transition metals, but they're kind of squeezed in there, and we'll talk about their properties and stuff in future lectures. But anyways, those are all the names of the groups on the periodic table and how they're further organized. And we're going to take a look, deeper and deeper into the periodic table next time, and we'll talk about the elements and all that stuff and how it relates to the periodic table in future lessons. Otherwise, that's the end of these notes, and we'll see you tomorrow in class.